And this will mark the beginning of video number 2 for our study sesh. I'm gonna invite some peeps here to join us. Okay, let's get some people to join here. Okay, Tiny, can you share your screen again, please? Because this time we're going to go through it. We're going to go line by line, and we're going to figure out the runtime complexity of the entire function by going through it line by line. And that will be very crucial for tomorrow. Okay. So great explanation there, Tani. So right now, like I just mentioned, we are going to be we're going to figure out the runtime complexity of the whole thing, but we're going to do it line by line, right? Okay. Sounds like Nyla's jamming out some music right now. Yeah. It's okay. Let's start with Jade. Jade, okay, so what do you know about like figuring out runtime complexity and how specific it needs to be? Like, what do you know about that? Do you guys read anything about that?
I didn't read anything about it, but I remember how Beach was kind of going through it and going through the overall part once, kind of like a first pass situation.
Yeah.
And trying to decide with each one whether it's going to be like an order of 1 or ON. And then once he figures out like kind of the first pass, then trying to simplify.
Yes.
And then combine and then go through like the process until you get it down to the simplest form.
Yep. So that's exactly correct. So basically what we're doing is, like you said, we're going to go through each line. We're going to like give the runtime complexity for that line or for that function as a first pass. You're going to go through and basically you're going to get rid of the fluff, the stuff that doesn't matter, right? Like if I have a for loop and then another for loop, they're not nested, they're separate. That would be O of n runtime, right? And then you have another O of n runtime. Granted that the stuff inside both the loops are like of O of 1, like constant runtime. So that would be n plus n technically, right? If it's inside of one entire function, but they're separate for loops. So that'd be like 2n, O of 2n runtime. But we don't care about the 2. We don't care about coefficients in this situation, unless it's like n log n. So yeah, exactly what you said. Use that the Big O cheat sheet that I dropped in the channel for you guys as like your reference. Really just want to stick to what they have there. So you can have something that's like linear or log of n. I'm sorry, constant or log of n or O of n, and then so forth, all the way up to n factorial. So let's start with the first line of the code. Let's go with Bryant, line 8. And then Tani, if you could you put in comments like next to the line, like what the runtime is specifically for that line? So like in this one right here, Bryant, what would the runtime complexity be of that 8 and 9, lines 8 and
9? Big O, 1 or n.
Give me your answer and then like why you think that's the answer, and then we can go from there.
So
like first, what is it doing? What is it doing?
Sorry, I thought it. So if there are values or cookies in the cache, then just return that. So it would just be 1 because like num cookies as the object doesn't multiply.
Not quite. Can I get somebody else to help Bryant out? Somebody? Okay, Nikki. No problem. Go ahead, Catherine. Oh, sorry, Nikki just said that she's going to leave.
Oh, well, I think this is just one.
And why?
Because it's constant. The constant operation. You're gonna just run it no matter what. Because a for loop would be n, and like if statements and stuff are constant.
Okay. What's happening to like the keys? So like, is there any sort of iteration that's going on here? Let's start there.
Oh.
Do you notice any iteration happening?
Well, you have to go through the cache to check. Yeah.
Right. So it does actually have to go through, and it has to like go through each and every single key, right? You're basically iterating through the object.
Yeah.
Yeah. So that's why I say like, I mean, you can generally look at the line and try to tell, but you have to know what the code is doing in order to really figure it out. Because if you have like a dot map function, it's not a for loop, right? But I mean, dot map, it iterates through an array and does something to each item in the array.
So that's 10, yeah. And then 10, 11, or 11, 12 will be 1. And then I'm not really sure about 15.
Okay. Hold on one second. Sorry about that. I had to tell my daughter good night. Okay, so let's see. We're looking at lines, which one now? Line 12, 11 and 12. Oh, we got that one. Okay.
Is it O of n then?
Well, I said for 8, that would be O of n, and then 11.
Sorry, that's what I meant.
Would be O of 1, but then with like 15, I'm not sure.
Okay, so 15. Let's see what we're doing on 15. So what is happening on 15? Somebody describe that process, please. Anybody? What's happening on line 15? Just like in general, what's happening?
This one's like the worst one, right? Because we're calling
the function 3 times.
Yeah.
Yeah.
In which so it's like a, what is that, factorial?
I don't know, 3 to the n?
Is it O to the n factorial?
Actually, I'm not 100% sure, so I'll have to look this one up. This is good though, because I need to know this as well.
It's really, really big, really fast. So that's why I'm thinking 3 to the n, but I don't know.
Let's see. Okay. So it says here, in order to find the big O for a recursive algorithm, you need to know the stopping criteria for that algorithm. But essentially it is like factorial. So it's going to be, yeah, it's going to be factorial. I don't think you're going to be multiplying them because they're being added to each other. So it'd be like factorial plus factorial plus factorial of n. So then it'd be like 3n factorial. So I think that's what we're going to go with until I let you guys know otherwise. But yes, it's going to grow really, really fast. Okay, and then lines 16 and 17. Lines 16 and 17. Somebody hop in and just make a stab at it. Make any guess. Any guess.
1?
Yes.
I'm still confused as to why 8 isn't 1.
Because you have to loop through the cache, because you have to check inside the cache. So anytime you're doing an iteration, it's n.
So if like 5 is in the cache, which is an array.
Object.
Yeah, so the cache is a dictionary. So every time that you run this code, you have to, whatever number of cookies, you have to go into your object and search it to see if you have that in there. So, and you have to do that every single time. So, but that's going to grow by n. It's not going to be constant because as the cache grows, you're
Okay.
going to search through more.
There's 10 cookies. There's 10 pairs in the cache.
Correct.
Okay.
Yep.
Okay, thanks. That helps.
Yep. If you just think of like the if, I think it comes from like if key in, and then like object, like that's the actual syntax of it. But we're using num cookies and we're using cache here in place of those actual other names. But yeah,
Okay.
you're basically doing like a for loop, but like for an object, because dictionaries are objects. Hash is like a dictionary. So yeah, you got to iterate. So anytime you're iterating through, there you go. That looks good. And then let's do the next line. Somebody want to jump on that next line? So what's happening on that line? Somebody? Tani? What's happening in line 19?
We're defining the value, which we were using throughout. So we're kind of just, we're setting it equal to the cache.
Exactly.
Meaning the.
So that would be O of.
And.
Well, you're only going to assign it one time, right?
Yeah. So 1.
O of 1.
Oh yeah, n was the wrong one. Sorry.
That's all right. Okay, so now that we have all of these individual like runtime complexities, like here's where, like on line 21, can you make a comment there? And like, can you just in a linear fashion going left to right, can you add them all up together, please? Like, can you do like O of n plus? Yeah, there you go. And then we're just gonna make it easy, kind of like how you did it on lines 31 to 37 there. You made it like visually easy to visualize. Yeah. So you have O of n plus O of 1 plus O of 1. Oh, no, sorry, plus O of, we got to put in the factor. Okay, yeah. Very nice. Okay, so how would you simplify this? Let's go, Catherine. How would you simplify this to the next line?
Well, you just do n factorial because that's the biggest thing.
Correct. We're not concerned with like coefficients that much, right? And then like the ones we can get rid of. But I mean, like just for simplifying purposes, like so people can see, like what would the next line be? How would you do that?
I mean, it would be 3 plus n plus 3n factorial.
Correct.
You'd just be like, well, and factorial is just a very, very big number, so.
Yeah. And so that's why we wouldn't be concerned with anything that's in front of it or behind it. Like we just know that n factorial is the largest thing.
Yeah.
Okay. So does that make sense to some people? That's why I really wanted to write it down and have it like visual for people to see. I mean, it's great when like we in our own heads know like what the final answer is going to be, but just trying to help people bridge the gap from the starting point to the end point for other people. There you go. Oh, you don't have to do it like that, Tani. Sorry. I'm sorry. Like you, yeah, you don't have to do it like that. I meant just like just combining like terms. I'm sorry, but you did display your mathematical prowess there.
Wait, so you
that's
want me to just put that like we have?
yeah, like so on the next line here, so you can get rid of that. Yeah, what you had it equal to. So on the next line there, you'd put like what Catherine said. You'd put like 3 plus O of n plus yeah, O of 3n factorial, because we're just combining like terms. And then, yeah, you delete that and you go down to the next line and we're like getting rid of the stuff that we don't need, right? So like we know that 3 is not going to really affect, like if we're looking at that curve and how fast it shoots up like that, like 3 is not going to really affect it. And then like O of n, that's not going to really affect it that much either. But like we have a 3 coefficient in front of the n factorial, like even that won't really affect it. Because n factorial just grows so quickly. So we can simplify it down to just n factorial, right? Which would be a factorial runtime complexity, which is like super bad. Not like the movie, like it's really like does not scale well at all. There you go. Very nice, very nice. Let me see if, did you guys learn? I feel like you guys didn't learn about space complexity, did you? You didn't really talk about that. Do you guys remember talking about space complexity?
No, it was never really brought up.
Okay.
It was
Yeah.
not, is it on the sprint? I don't.
Man, when I went through this, we had to worry about space complexity. You guys don't, doesn't look like space complexity is an important thing to remember for this exam. So, yeah. Okay, cool. So what do we cover? We covered big O notation. We covered recursion. We covered we deep dived into recursion. And then the last thing that you're gonna have to be very familiar with. Okay. All right. Okay. All right. So last thing you're gonna have to be very concerned with is, obviously you guys know sorting, which is not all that important for interviews, but obviously they need to make sure that you can master this so they can say that you participated in a mastery-based program. Where's my Zoom? There you go. Okay, so last week you guys did your Python sprint. Make sure you know like classical inheritance. So you'll kind of use that. I mean, you're expected to know stuff that you've covered in the past, so you know that. But you're going to be using that knowledge that you used last week to create some sort of sorting algorithm. I would just, it's a big problem. I would highly suggest you use Polyas and you just break it down into small steps. Like, just like you did for the cookies, like the rock, paper, scissors the other day. Just, it's gonna seem almost overwhelming to you. It's just a big problem. You just break it down into steps. So anybody have any questions on that then? I feel like I can't give you any more than that.
We'll see how it goes tomorrow.
Well, I mean, I'm going to be here anyway, so you guys can hit me up, and I'm more than happy to give you guys clues but not give you the answer because there's nothing valuable in that. But yeah, for sure, study the big O stuff. You're gonna have to know that anyways for interviews. Like if you can write an algorithm, but you can't describe the runtime complexity or space complexity of it, for this sprint, you won't have to do the space complexity, but runtime complexity is pretty important. Yeah. So any other questions or anything?
That's it. Thank you.
Bryant? All right, Catherine, get some food. Brian, you're super clear on the iterating through an object? Have you ever done
Me?
that? Yeah.
Iterating through an object?
Yeah, like the like if
What, a dictionary?
yeah.
Yeah,
if
yeah,
key,
yeah, yeah.
If key and if key and
Yeah,
cache.
yeah.
Okay.
I just didn't. I didn't implement the cache yet, so I just didn't know what type
Okay.
of object that was until just now.
Okay.
Yeah. I get it now. I just yeah, it makes sense.
Yeah, so you can think of it like a for loop in terms of the runtime complexity of it, because you have to go through every single key in that object when you run like a if key in cache or if key in object.
Right.
It's the same thing as like a for loop.
Yeah, you're almost like a filter or something. Yeah.
Okay.
Yeah, I get that.
All right, Tani, you clear on everything, or you need any more clarifying?
I'll probably have questions tomorrow and wish I had asked you today. But I can't think of anything except which module was today's?
Today's, yeah, algorithms.
It's like writing something.
Oh, how to write and analyze.
Yeah.
Same.
Yep.
Okay, thank you.
No problem. All right, y'all, get some rest. Don't freak out too much. You'll be okay. If I made it through, you can make it. It took me 12 hours, but I made it. So.
Fun. All right.
All right, guys. We'll see you. Have a good night.
Good night.